CryoHeat wear resistance. Where at? Where is it at? Where is it located? No, wear resistance, like wearing out parts. So the CryoHeat process for parts that will wear out. So obviously, if something is connected to a shaft and the shaft has bearings pressed on it and there's nothing touching that shaft at all and it's spinning around in circles, there's nothing really wearing out. But a really good opportunity to see something that's going to wear out, say a gear in a transmission. Let's say it's a gear in a transmission for a vehicle or a piece of machinery. It could be on a plant floor that is running at 2,000 RPMs 24/7, and only once a year it might have to be removed and replaced because the teeth didn't break, or the transmission gear or whatever, the part didn't actually physically break, it just literally wore out. So this is where CryoHeat and the CryoHeat process makes a huge, like, astronomical, like, I can't even explain to you, especially with the right material, like 4x. Like, imagine a part lasting 4 times longer just from this. The wear resistance really falls into play mostly with steel, and if you have a decent amount of carbon. So again, going back into those carbon, like the chromoly family, like there's the second number is going to be a part of the number of how much carbon is actually in that steel. And then you get into tool steels, like D2 tool steel, S7 tool steel, H13 tool steel, but then leaning more onto the motorsport side, 8620 or a 4140. You get into this type of stuff at 300M. You have enough carbon in that material where the process just makes the material go bonkers, and let's talk I'm going to talk a little bit about austenite. Austenite is a premature martensitic carbon. Look it up. Martensitic carbons are very expensive when the carbons are added into materials. A premature martensitic carbon, austenite, is basically like street terms popcorn of metal. It's dog crap. You don't want it in your metal. It's very brittle and it causes problems. You cannot get away with it, or you cannot get away from it with traditional heat treating and traditional manufacturing methods without deep cryogenics, cryoheat processing. Our processing under a microscope has been 100% proven that it literally makes an austenite into a martensitic carbon. So anywhere where there's microscopic austenite, it will turn into martensitic carbons. And if there's a microscopic fissure next to that next to the austenite, it will turn into 2 times, so twice the amount of martensitic carbon. Martensitic carbon is literally a carbon that is like a self-lubricator. So when you have 2 pieces of metal, like gears, running into each other constantly to the point where they don't break, but they wear out, you look at materials that you want to use that have high carbons and ideally a martensitic carbon. Well, our process makes that actually work out for its hugest benefits. And I guarantee you, like, we've worked with so many manufacturers of literally whether they're manufacturing the part or they're a manufacturer and they have a gear that just ends up wearing out every year, but it costs $100,000 to shut the plant down for a day to replace those gears. We cryoheat process those parts for them, and instead of every year, it's every other year. We're saving them $100,000 a year for not having to shut the plant down. That's huge. And then with a lot of our UTV guys that are utilizing our CryoHeat branded parts in their transmissions, the proof's in the pudding. I mean, a lot of these transmissions that are being raced by somebody who for instance, desert racing, they're putting 4, 5, 6,000 miles on our transmissions of race miles, and that is literally unheard of at that level. So it's another really good one.